Hello students and welcome to the lecture. So students, as you can see over here that basically in this lecture, we are going to start our discussion over the Newton's laws of motion. Okay. And that is going to be our part 1. Previously we have done with the motions. Now we are going to talk about the laws of motion. And here we will also talk about the Newton's laws of motion. Okay. I hope you have revised our previous 2 lectures in the well enough manner, because it is important to revise the facts and figures before going to the next topic. In this lecture, we will talk about the introduction to the Newton's laws of motion, Newton's first law of motion, second laws of motion, application of the concept of impulse, Newton's third law of motion, and at last we will see the summary of all these. But as always, before starting this, we have a small disclaimer over here that we all are required to understand first before we proceed further. So the disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at SATHEE-RRB@iitk.ac.in and we shall remove the images. Now, let's begin with the introduction. So that was the year of 1687 when the Newton, who is often called as the father of physics, he described the law of motion and he wrote a book called Principia where he defined this concept of laws of motion, or you can say describe this concept of laws of motion. Newton stated the following 3 laws of motion, because in the index we had seen that there are the 3 laws of motion. So when we try to track them down, first is the first law of motion that we have to discuss about. So in his first law of motion, he said, a body continues to be in states of rest or of uniform motion in straight line unless a force is applied on it. What means, if there is any body that is in a rest position, it means it is not in a motion, it is in the rest. Okay. So that body will remain in the rest till some force will apply on it, so that the body should change its initial state of resting to the you can say motion state. Second, he said, if instead of resting there is any body that is in the state of motion or uniform motion basically, so that body will continue its uniform motion state unless external force applied on it, so that that moving body or that uniformly moving body must change its state of movement. Okay, that was his first law. Like the any body which is in the any state of rest or uniform motion, that body will not change its state until or unless any external force applied on it. This law, also called as a law of inertia or law of Galileo. Why? Because in Galileo in 17th century laid the foundation of Newtonian mechanics, which signaled the birth of modern science. So that's why it is also known as law of Galileo. Newton's first law could be understood in the following 2 parts. First, definition of inertia. Second, definition of force. First, definition of inertia. In the first part, Newton's first law gives the definition of inertia. Okay. According to which an object couldn't change its state by itself. Like you can say, if you see any object which is in the rest or which is in the motion, that object will not change its state of motion or resting by itself. Like you can say, if you're seeing a book on a table, okay, if you are seeing that book will not automatically start moving, because right now the book is in the state of resting, but by itself the book will not start moving. Okay. Similarly, if you are seeing a serve movement of a body on a linear motion, then that body will not stop by itself. Okay. Like no body could change its position by itself. If the object is in the state of rest, it will remain in the state of rest. And if it is moving in the some direction, it will continue to move with same speed in the same direction. The condition is unless an external force is applied on it, which means we required some external force to be applied on a particular body if we want to change its state. Whether the resting state, we want to make it move, whether moving state, we want it to rest. Okay. So in both the conditions, we required some external force. In other words, we say that inertia is actually an inherent property of each body by virtue of it having a tendency to resist the change in its state of rest or state of motion. Like every body which you are seeing having some inherent property in itself due to which it, if it is in rest, it will in the rest. If it is in motion, it will in the motion. The property of inertia is because of mass of the body. The greater the mass, the greater is the inertia of body. Okay. Thus, a lighter body has less inertia than a heavier body. So we say that mass is a measure of inertia. So remember this point. The property of inertia through which the body resists the change is because of the mass of that body. The greater the mass, greater is the inertia of body. Lighter the mass, lighter will be the inertia of body. And basically, mass is a measure of inertia. For example, a cricket ball is more massive than a tennis ball. A cricket ball acquires much smaller velocity than a tennis ball when the two balls are pushed with equal force for the same duration. In case when they are moving with the same velocity, it is more difficult to stop the cricket ball which has more mass in comparison to tennis ball. Like if you in your childhood play a cricket, so you must have played with these balls, right? This is we know leather ball, this is we know tennis ball. So leather ball in comparison to the tennis ball is heavier and massive. Okay. So when, if you are a batsman, suppose now you are a batsman, if the bowler is throwing tennis ball towards you and you have to stop the ball with your bat, so you will require a less velocity and less force to stop the tennis ball. You could easily handle it. But when it would be a leather ball, then your velocity will be higher and even it will require some extra effort to handle the leather ball because the mass of the leather ball is higher in comparison with the mass of the tennis ball. Okay. So the inertia of leather ball is higher in comparison of inertia of tennis ball. Kinds of inertia, if we talk about, so inertia is of the following two kinds. Inertia of rest, first kind, inertia of motion, second kind. Like inertia of rest. If a body is at rest, it will continue to remain at rest unless an external force is applied to change its state of rest. Okay. When a train moves forwards, the passenger standing in the compartment tends to fall backwards. Why? Because the train and the passenger, they both are different bodies. Okay. Like here you can say the person who is standing in some train, the train having its own body and the person having its own body. So if the train starts move forward, then the train has changed its initial state of resting because some external force applied on the train. So that's the train starts moving. But the passenger who has a different body, he is not experiencing any external force. So that's why his body will not change its state of resting. So that's why when the train moves forward, okay, you lean backward because you can say in reference of the train, your body is at rest. Or you can say if you look at this picture carefully, then you can understand it better. Now we will change some facts. Instead of moving the forward, the train stops. Okay. So whenever the train stops, so you can say your body was also in a motion with respect of the train. Okay. But some external force applied on the train. so that the train change its motion state with the resting stage. The train stopped, but you are the passenger who was in a motion but having a different body. No force applied on it. So you can say if you were moving in the train stopped here at that point. But your body, because your body was in a motion and not experiencing any external force, so that your body should change the state of motion into the resting. So what will happen? You will lean forward. Why? Because your body is still in a motion, but train is not. Okay. So when the train stops, you will move forward, and when the train starts, you lean backward. I hope that is clear in your mind. This is so because the lower part of the body of the passenger is in close contact with the train. As the train starts moving, the lower part of the passenger body shares the motion with train. Okay. But the upper part, which is not in the close contact with the train, cannot share the motion simultaneously. So it tends to remain at the same place. That's why you lean backward. Okay. Consequently, the lower part of the body moves ahead and the upper part is left behind, so the passenger tends to fall backward. Similarly, here you can say this is your lower part. Okay. So your lower part is in the close contact with the train, but your upper body is not. So when the train stops, your lower part also shares the motion, but your upper part is not. So your upper part is still in the motion. That's why you move forward. Okay, but your lower part not that much. So when a hanging carpet is beaten with a stick, the dust particles start coming out of it. Why? Because whenever you can say beat the blanket with the stick, so the stick pushes the blanket away, but the particles which are inside the blanket, these particles not sharing the motion with the blanket, so they will remain at their place, but the blanket will move backward, so the dust particle will coming out of it. The reason is that, as I have told you, the part of the carpet where the stick strikes comes in a motion, but the dust particles settled on it remain in the state of rest due to the inertia of rest, because they are not sharing any motion or not experiencing any external force. Thus, that part of the carpet moves ahead, leaving behind the dust particles which fall down due to the Earth's gravitational pull, and that's how the dust removes from the blanket. Now the second type was the inertia of motion. So a body in a state of motion possesses the inertia of motion and continues to be in the state of motion with the same speed in the same direction in a straight line unless an external force applied to it to change its state. Got it? Example, a person riding a bicycle along a level road does not come to rest immediately after he stops pedaling. Like you can say, if you ever ride a bicycle. So suppose you are pedaling the bicycle, but suddenly you stop pedaling. So what will happen? You will stop? No. It will take you some time to get stopped. Why? Why? Because your cycle is in the state of motion. Okay? And it is not experiencing any external force to stop it. So when you stop pedaling, no external force is applying on it. We are not considering the friction here. We are just saying, for example, no external force applied on it. Then what will happen? The body, the cycle will still continue in motion. The bicycle continues to move forward due to the inertia of motion because the bicycle is not changing its initial state. But eventually it comes to a rest as a result of retarding action of friction. Like you can say, suppose if you are riding a bicycle, then, or you can say this person is running. Okay. So if this person is running and he stop running, what will happen to it? Is he stop immediately? No. He will run, maybe slow down till some place and then he will get stopped. Why? Because he is in the motion. So his body will show the inertia of motion. His body will resist the state of resting because the body is in the state of motion. But when the friction, which is the external force applied on the body will eventually losing the movement because of the retarding action of friction. Okay. A ball thrown vertically upwards by a person in a moving train comes back to his hand due to the inertia of motion. Okay. A person often runs before taking a jump. This reason is that by running first, he brings himself in the state of motion, and then it becomes easier for him to take a jump because now he has gained what? Momentum. Okay. When a running car stops suddenly, the passenger is jerked forward due to the inertia of motion. Why? Because suppose right now he is driving a car. His lower part is in the close contact with the car. So while the car is in the motion, his lower body is also in the motion. But his upper body is still in the state of rest. So when he stops the car, his car and his lower body, because they are sharing the same kind of state, so they will stop. But his upper body, which is not in the close contact with that, the body will lean forward because the body is in the motion. The property of inertia is because of the mass of the body, as we had just seen. Greater the mass, the greater is the inertia of body. Newton's first law of motion gives us the definition of force in a qualitative way. Therefore, a force is the cause that could change the state of rest or of uniform motion of a body. Now, what is the second law of motion? First we have seen. Now the second law. So the rate of change of momentum of body is directly proportional to the force applied on it, and this change takes place in the direction of force. The law leads the force F to mass m and the acceleration a of the body. They are rated as E is equal to ma. Like you can say here it is. So if you want to push it away, suppose this is a slab, circular slab. This circular slab is of 40 kg and this circular slab is of 400 kg. If I ask you, you have to push it away, what slab will be easier for you to push? 40 kg or 400 kg? Obviously 400 kg. Why? Because the 400 kg will have more mass in comparison to the 40 kg. So if you want this 400 kg, which is in the state of resting, to move, it means you have to change the momentum of this, and that will require a higher force in comparison with the 40 kg slab to move, and that movement will be in the direction of force. Like if you see this picture, what you are seeing, that person is happy when he has to move this 40 kg slab. He is tense when he have to move this 400 kg slab. Okay, and you can say when he's moving this, he applying force in this direction. So again, the slab is moving in the same direction where the force is being applied. This magnitude of force could be calculated by multiplying mass of the body and the acceleration produced in it. Hence, second law of motion gives us a measure of force. Unit of force, the force unit are of two types: absolute unit, first type, and gravitational units, second type. Absolute unit of force on SI unit is Newton N, and on CGS system it is dyne. Okay, like 1 Newton is equal to 10's power 5 dyne. The gravitational unit of force on SI is kilogram weight or kilogram force. Thus, 1 kilogram, or you can say 1 kilogram weight or 1 kilogram F is equal to 1 kg into 9.8 meters per second is equal to 9.8 Newton. Okay. The gravitational unit of force in CG system is gram weight or gram force. Thus, 1 gram watts is equal to 1 GF is equal to 1 G into 980 centimeters second minus 2 is equal to 980 dyne. Now what is momentum? So the momentum of a body is the product of its mass and the velocity. Okay. For a body of mass m moving the velocity v, the momentum will be m into v. It is a vector quantity because it's having the magnitude and direction both. It has same direction as the direction of motion of the body. The SI unit of momentum is kgms minus 1 and the CGS unit is gcms minus 1. Rate of change of momentum is equal to the force. Like the much force, the much change of momentum will be. Lesser the force, lesser the change of momentum would be. What is the impulse now? So basically we talk about impulse. Impulse is also the type of force. But the force which act on a body for short time, these are called the impulsive force. Like you can say these only applied for the short duration. Like in hitting a ball with a bat. So the bat will hit the ball and then the force will be disappear. It is for the short duration only. In driving a nail into a wooden block with a hammer, when you push the hammer on the nail, you applied a force. But while you are pushing the hammer only, then the force will be applied. After that, the force will not. In firing a gun, etc. Okay. So impulse is that force which applied for very short duration only. An impulsive force does not remain constant but changes from 0 to maximum and then from maximum to 0. Like suppose you are not hitting the ball having a 0 force. But when you hit the ball with bat, the ball having a maximum force. But once the bat having no contact with the ball, again the ball will start losing the force from maximum to 0. So this is the criteria. Thus it is not possible to measure easily the value of impulsive force because it changes with time. Immediately it is from 0 to maximum and then after maximum to 0. In such cases, we measure the total effect of the force called the impulse. Hence, impulse of a force in a measure of total effect of the force. Impulse equal to average force into time, or this is the formula you can see here. Hence, impulse of a force, which is actually the product of average force during the impact and the time for which the impact lasts, is measured by the total change in linear momentum produced during the impact. Like if you go to measure the force, okay, then it is not possible. Why? Because the impulse having a very short duration. So it is hard to measure it on that time. But instead of measuring the force, you could measure the impact or total change of the force. Like if you hit a ball with the bat, you are not able to measure the impact of force on that time because it is for the short duration. The contact is short. But after this, if you try to measure the total change that comes in the linear momentum of the ball because of the impact while hitting the bat, then you could measure the impulse of a force. Impulse of a force may be positive, negative or 0 according to the momentum of the force, increasing, decreasing or remains unchanged under the effect of force. If it is increasing, the impulse of force positive, decreasing, impulse of force negative, it is remains unchanged, the impulse of a force is 0 or neutral. Impulse also a vector quantity because it is having a direction of magnitude. The direction is the same as that of the force applies. The SI units of impulse are Newton second, NS, and kgms minus 1, and the CGS unit of impulse are dynesec and CGMS. Impulse of a force is equal to area enclosed by the force curve and the time axis. Like you can say, this is the time axis, this is the force. So this is the maximum value, maximum force or maximum time. Okay, like here you can say it is 0. Suddenly it reaches the maximum and then it from maximum to 0 again. So that's why it is said as a short impact. Now the application of the concept of impulse. A cricket player lower his head while catching a ball. Why? Because a player do so because he allows a longer time for his hand to stop the ball. Like if he will try to stop it here, the impact on his hand will be higher because he will try to absorb the force of this momentum into his hand. But when he will take his head down with the movement of the ball, slowly the ball will lose its movement and the impact on his hand, on the hand of the player, will be lesser in comparison with the immediate one. When a person falls from a certain height on a cemented floor, the floor does not yield. The total change in the linear momentum is produced in a smaller interval of time. Therefore, the floor exerts a much larger force on the person rather than the person exerts a force on floor. Due to it, a person receive a more injury. Why? Because he receive a higher impact of force in comparison with the floor, which receive a lower impact of force. On the other hand, when a person falls on a heap of sand, the sand yield. Why? Because the same change in the linear momentum is produced in much longer time. Okay, because when you falls on a heap of the sand will settle down slowly, so the impact will be lesser. The average force exerted on the person by the heap of sand is therefore much smaller, and that's why the person is not get hurt. China wares and glassware wrapped in paper or straw pieces while packing. Why? Because in the event of fall, the impact will take a longer time to reach the glass or china wares through paper and straw. As a result, the average force exerted on a china or glassware is small and chances of their breaking is reduced. The vehicles like scooter, car, bus, truck, etc. These are provided with shockers. When they move over an uneven road, the impulsive forces are exerted by the road. The function of shocker is to increase the time of impact. Like this is the tire, this is the vehicle body, and here you can say it is a shocker. So when the tire experiences the impulsive force, because of shocker, it takes a longer time to reach the main body of the car. So that's why the time of impact will be higher and the force impact will be lower. This would reduce the force jerk experienced by the rider of the vehicle. Bogies of a train provided with the buffers avoid severe jerks during the shunting of the train. Due to the presence of buffers, time of impact increases. Therefore, the force during jerks decreases. Hence, the chances of damage decreases. Newton's second law is the fundamental law of motion. First law of motion is also included in the second law. We could obtain Newton's first law of motion from second law of motion. From Newton's second law, we could say F is equal to ma. If F is 0, then acceleration is also 0. Okay. The mass alone could not generate the force. It requires the external force and acceleration. This means that if no force is applied on the body, the acceleration will be 0. If the body is at rest, it will remain at rest, and if it's moving, it will remain moving in the same direction with the same speed. This is the statement of Newton's first law of motion that we have just seen. Now the third law. According to the Newton's third law of motion, to every action there is always an equal and opposite reaction. Okay. The action and reaction equal in magnitude and opposite in the direction. The action and reaction do not act on the same body. If action is one body, reaction will be on the other body. Like here you can say, if you use this, okay, so now you can say there is an action. When you burn this will generate a force on the top or the cannon on the back side. And similarly, when the action happens here, the same force the cannon will generate on the bomb in the in front side. That will be in the reaction. Okay. So now you can say if the action was happened on the cannon, the reaction is happening on the bomb. And that is what we had seen. Action is on one body, reaction will be on another body. And that force which the cannon experience, the same force the cannon will exert on the bomb with the same magnitude and opposite in the direction. If AB is the force exerted on body A by body B, therefore action, and is the force exerted on body B by body A, therefore reaction, then according to Newton's third law of motion, FAB is equal to minus FPA. The third law of motion tells us what is the origin of external force on the body. According to Newton, force never occurs singly in nature, it will be dual in nature. Force always occurs in pairs as a result of mutual interaction between two bodies. Some examples, Newton's third law of motion. Book on a table. So now you can see, when a book placed on a tabletop, the book exerts a force on the table which is equal to the weight of the body. This may be called the force of action. Table supports the book by exerting an equal force on the book. This is the force of reaction. Since the book absorbed to be rest, the net external force on it must be 0. Implies that the normal reaction must be equal and opposite to the weight of the body. Walking. While walking, a person presses the ground in the backward direction, action by his feet. The ground pushes the person forward direction with an equal force, reaction. Component of reaction in the horizontal direction makes the person move forward. Firing from gun. When a gun is fired, the bullet moves forward, action. The gun recoil backwards, reaction. Flight of jet planes and rocket motion. The burnt fuel, which appears in the form of hot and highly compressed gases, escapes through nozzle, action in the backward direction. The escaping gases pushes the jet plane or rocket forward, reaction with the same force. As the jacket or rocket moves, motion of boat away from the shore. When a boatman wants to move the boat from the shore, he pushes the shore with his oar, action. As a reaction, the shore pushes the boatman along with the boat with that an equal and opposite friction. We have finished the topic. Now it's part for the summary discussion. We have talked about when the Isaac Newton in 1687 described the laws of motion of the classic mechanics in his book Principia. We had discussed the first law of motion, inertia, two types of inertia, second law of motion, the unit of force, momentum, vector quantities, impulse we have discussed, Newton's third law of motion we had discussed, examples we have also discussed, and second law as a fundamental we had discussed, which also describes the first law. With this, we have finished this part. It is requested to all of you. Kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.